All right, welcome to 8.5 conditional probability. I've been having a hot mess central with these note cards and having to change note card numbers. So I've double checked, so I'm pretty sure these note card numbers are right. Okay, so note card 277, conditional probability. What is conditional probability? Well, given that events A and B, so you're given two events, A and B. Conditional probability is the probability of event B occurring knowing that event A has already occurred. And you can also say it the other way, like event A is occurring knowing that event B has occurred. So the A and B guys are just parameters. They're just standing for an event, like drawing a queen out of a deck of cards, or rolling a 4 with a standard die. All right. The notation of how this is worded, because it's worded with B occurring, knowing that A has already occurred, is the probability of B given that's normally a straight up and down line. It's kind of slanted right here, but given that A has occurred. Okay, so that you read this as the probability of B given A, or the probability of B given that A has occurred. This formula is super important. So the probability of B given that A has occurred is equal to the probability of A and B divided by just the probability of A. So I want you to pause and write all of this down, and I'm going to keep going over this as we go through the next slides. Card 278, I want to do an example of conditional probability, and I have popped the formula in right here for us to reference if needed. Okay, so it says Mitchell drew a card from a standard deck of playing cards. What is the probability that he drew a queen given that the card was red? Okay, so what do we have going on here? Well, I went in right here and put the letters that make sense to me in context of the problem. So the probability that he draws a queen given that vertical line means given that the card was red. Okay, the card is red. So using this formula, it would just be the probability of Q and R. Now I know they put A and B. It's just probability that it's queen and it's red over the probability that it's just red. Okay, so let's look. To find the probability of drawing a queen and it being red, well, there are 26 red cards in a 52 deck, and there are 4 queens. So that's queen and red. You just multiply. And on the bottom, the probability that it's red, there's 26 out of 52. Now, I kind of think using this formula on this one's silly because it takes away the common sense. But and I'll talk about that in a second. So right here, these 26 out of 52 is crossed out. You're just going to put 4 out of 52. That reduces to 1 out of 13. Of course, you can just type it in the calculator. But guys, let's think about it. What's the probability that you're doing this out of it being red, okay? So we know it's going to be over. There's only 26 reds, okay? And then how many queens are there in the reds? Well, there's a red heart and there's a red diamond. So there's 2. So it would be 2 divided by 26, which reduces to 1/13. Okay, so you can just think about it that way on a lot of these. You don't have to use the formula. You only have to use the formula if you can't figure it out that way. So I hope that makes sense. But anyway, pause me and finish up note card 278. All right, this one's not a note card, but I do want to talk about it. A number from 1 through 100 is randomly selected. What is the probability that is a perfect square, let's just say square, not square, given that is an odd number? Okay, so a perfect square given that is an odd number. Okay, so I wrote it in the context of the problem. The probability it's a perfect square given that it's odd. So it's going to be equal to the probability that it's a perfect square and odd divided by the probability that it's odd. So I went ahead and listed out the perfect squares for you, the numbers 1 through 100, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and so on. And then of course your odd numbers, there's 50 of them. It's half of them are even, half of them are odd. I just started with the list of odd numbers just to make sure. All right, so if I want it to be a perfect square and odd, I highlighted those yellows. There's 5 of them out of a total of 50 odds. So 5 out of 50 is 1/10, guys. That's the answer. So on this one, I don't necessarily need this formula, but if I want to, oh no, didn't mean to do that. If I want to use the formula, here we go. The probability that it's odd is going to be 50 out of 100. Probability that's a perfect square, there's 10 of them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 100. And then divided by the probability that it's odd is 50 out of 100. You do that in your calculator, and you're going to get 1/10. All right. Now, let me make sure I have the right note card number. Yes, so note card 279, I want to do a conditional probability example where we use a Venn diagram. So there are 62 people that take yoga class and 48 people that take spinning class at the gym. 15 people that take yoga also take spinning. So we have like a joint thing here where some do both. And so that begs a Venn diagram where it says 15 people take yoga and they also take spinning, okay? If a person from these groups is selected at random, blah, blah, blah. So I want to show you first this right here. So when you have a joint, like somebody plays soccer and does track, and you have some that don't do one or the other, that, like I said, begs a Venn diagram. So here's a Venn diagram. 15 goes in the middle because 15 people do both yoga and spinning. Now, it says 48 people take spinning. So from that, I know 15 do both. So I do 48 minus 15 and get that 33 just take spinning. Now, it said a total of 62 people take yoga. So I do 62 minus 15 and I get 47. Okay, so that's how those numbers are generated. So here's your Venn diagram. And now it says if a person from these groups is selected at random, find the probability that he or she is taking yoga class. If you know they take a spinning class, here's the notation that the probability that they take a yoga class, given that they take a spinning class. I know it doesn't use the verbiage given that, but if you know that, that's the same thing. If you know they. And so that is equal to the probability that they take yoga and spinning divided by the probability they take spinning. And here's where I really do use this formula. You don't have to. Some of you have maybe a little more common sense, but for me, it's easier to use this formula on this one. And so what is the probability they take yoga and spinning? That's 15. Out of the probability they take spinning, well, how many was that? That was 48. So 15 out of 48 reduces to 5/16. Go ahead and pause me and finish up note card 279. Here's another one that is not a note card, but I do want to go over it. There's 30 students in Mrs. Smith's math class, 13 are athletes, and 9 are in band. Three of the athletes are also in band. So we have a Venn diagram because 3 do both. You subtract 3 from 13 and 3 from 9 and get that 6 are only in band and 10 are just only athletes, but 3 are both. Now here is the notation. I went ahead and typed that up. The probability that they're in band, they're not an athlete, given that they're not an athlete, is equal to the probability that they're in band and not an athlete over the probability that they're not an athlete. Now, one thing about this Venn diagram, it doesn't include those that are not athletes. Like as far as not an athlete or in band. So let me see if I can get this to work out right. All right, so this would be, we have an outer part of the Venn diagram, and we know there's 30 students total, okay? There's 30 students. So 13 are athletes, 9 are in band. So let's see, 10 plus 3 is 13 plus 6 is 19. So that leaves 11 just outside of this Venn diagram, okay? So when I go to do this, let's see. All right, so I have 11 students who aren't an athlete and they're not in band, okay? So now to answer the question, which ones are in band and not an athlete? That'd be 6 of them. So at the top would be 6, and on the bottom, they're not an athlete. Okay, so we know that we have 6 that are in band that are not athletes, but we have 11 students who are neither. So 6 plus 11 is 17. So the probability is 6 out of 17. You can see there how it can get kind of tricky, okay? Now, the next one is note card. Make sure I got the numbers right. Yeah, note card 280, where we're going to be talking about two-way tables. These are a table that records data that pertains to different categories. So for example, the table shows the results of a poll of 50 randomly selected students who were asked whether they prefer to watch hockey or football. So you had 50 students that were asked. All of these will add to 50. 18 boys said football, 6 girls said football, 10 boys said hockey, 16 girls said hockey. All right, so using the two-way table, what's the probability that they prefer football given that they're a girl? And using the formula, that would be the probability that they prefer football and they're a girl. So that would be 6 out of the probability that they're a girl. And that's out of 22. So it'd be 6 out of 22. which would be 3/11 because it would reduce. Let me talk about that again because you're probably not paying a whole lot of attention. You're just doing your note cards, doing your thing. Make sure you follow me there. This would be the probability that it's both of these. So that'd be 6 girls that prefer football divided by, I'm using the formula, the probability that they're a girl. Well, there's only 22 girls if you add these up. So 6 out of 22. So what's the probability that they're a boy given that they chose hockey? Okay. So on the top would be the probability they're a boy and they chose hockey, so that's 10. Divided by the probability that they chose hockey. So it'd be 10 out of 26 because there were 26 people that chose hockey, which reduced to 513. So pause me and finish up note card 280. All right, on to note card 281. We're going to do an example of this. So I know the last note card kind of had an example with it, but this is a more, I guess, extensive example. Okay, so what is the probability that there's a 7th grader who takes French? This is not a given, that one. Just look, the 7th grader, there's 150 students that were selected. So that'd be all you have to do is 25 out of 150, okay, which reduces to 1/6. Now, this one has the given that. What's the probability they're an 8th grader given that they take Spanish? Okay, so we need to think about the formula. That would be the probability that they're an 8th grader and they take Spanish. Okay, so 8th grader takes Spanish, that'd be 33 divided by, okay, so 33, yeah, okay, divided by the probability that they take Spanish. So I have to add all of these up. So 23 plus 12 plus 33 is 68. So 33/68, that does not reduce. Now, part C, what is the probability to take French given that they're a 6th grader? So French given they're a 6th grader. So what's the probability they take French and they're a 6th grader? That's 19 on the top. Okay, so you'll have 19. And on the bottom, what's the probability they're a 6th grader? So what's 19 plus 23? That is 42. And that does not reduce. So it's just 19/42. Part D, what's the probability that they're a 7th grader given that they take French? So 7th grader French, there's 25 of them, and it needs to be out of the kids that take French. So that's 19 plus 25 plus 38, which is 82. So 25/82. So if you look, A and D are different questions, even though they both talk about a 7th grader and taking French, okay? This part A didn't say given that. Part D did. So I hope you see the difference. So pause me and finish up note card 281. Here's another example that is not a note card, but this shows the results of randomly selected juniors and seniors who were asked if they attended prom. So did they, yes or no? Here's the data. There's 200 total. What's the probability that they're a junior and they did not attend prom? This is not a given that, okay? So a junior that did not would be 56 out of the 200 total. Part B, the probability that did not attend prom given that they're a senior, okay? So what's the probability they did not attend the prom and they're a senior? That's 19 out of a total of 116 seniors because you have to divide it by the amount of seniors. Part C, the probability they're a junior given that they attended prom. So juniors attended was 28 divided by if they just attended the prom. So if I do 28 plus 97, I get 125. All right, note card 282 is just simple notes about frequency. There's something called a joint relative frequency. These are the values in each category divided by the total number of values. A lot of times called relative frequency, not joint relative necessarily, but relative. Oh, sorry. And then there's a marginal relative frequency. It's found by totaling each row in each column. So go ahead and pause me and finish that up, writing down those things in that note card 282. And then the last note card is 283. What I want to do a frequencies example. So the table below shows the number of first class and coach class passengers on a plane who checked 1 bag, 2 bags, or no bags. Like when you check a bag, that's what goes under the plane when you fly. Find the joint relative and marginal relative frequencies, and then find each probability. Okay, so here's the data. There were 160 total passengers. So to find the joint relative frequencies, remember, it's the values in each category divided by the total number of values. All right, so right here we had 16. So 16 divided by 160 is going to give me 0.1. Okay, how many of the first class had 1 bag? There's 12. So I'm getting my calculator, doing 12 divided by 160. That's 0.075. Okay, and just so on. You do 12 divided by 160, you get that, and you just add all of those up, and there's the number that you get. Now remember, when you add them up, that is the marginal relative frequency. We don't have to be too worried about these, knowing exactly what each of these means, but you do need to know how to find these decimals that I did. Okay, coach class, you do 52 out of 160, and you get 0.325. And then so on. So you would do 60 out of 160 and 18 out of 160, and then add them up, and there is your marginal, okay, your marginal relative frequency. And then you just add across, okay, and you add down, and they're all going to add to 1. It's kind of interesting. Anyway, that is your relative and marginal frequency table. So now we answer the questions. Find the probability that a coach class passenger of, let's see, find each probability. A coach class passenger that did not check any bags. So they're coach class, okay, but they did not check any bags. So how would we do that? That's right here. They're coach class and they did not check any bags. And that you can write as 0.1125, or just you can make it a percent if you want, like they did here. Part B, what's the probability they're a first class passenger? So we're right here, that checked at least 1 bag. So that's 1 bag and also 2 bags. So you'd have to add 0.1 and 0.075 to get 0.175. So that's 0.175, or you can write it as 17.5%. All right, so here's where the conditional comes in. Find the probability that they are coach class given that they checked 1 bag. So remember the formula. That would be the probability they're coach class and they checked 1 bag, which is right here, 0.375, divided by just the probability they checked 1 bag. And so that would be 0.45. So 0.375 divided by 0.5, you type that in the calculator, you get 0.83 repeated. So it's about 83.3%. Right here, another given that, or conditional probability, the probability that they checked 2 bags given that it's first class. So remember the formula, it would be the probability they checked 2 bags and it's first class, which is right here, so 0.1, divided by the probability they're first class, which down here in the total column is 0.1875. So you type that in your calculator, you get 0.53 repeated. So that's about a 53.3% chance. Oh my goodness, that was a lot to say. But rewind me if you need to. Finish up your note card 283. Oh, and did you get this far? If you did, awesome. Doing a great job. I know we're about done, and I know it'd be really easy to just, really tempting to not watch the video and to just fly through this. If you got this far, send me an email that says, I made it to the end of the 8.5 video. Thank you guys. Bye-bye.